Hi everyone, welcome to Numeric Learning. In today's video, let us do the NCERT Exemplar Exercise 2.4 of the chapter Polynomials. So this is the fourth exercise. The question is as follows. For each of the following, find a quadratic polynomial whose sum and product respectively of the zeros are given. Find the zeros of these polynomials by factorization. So you first have to find a quadratic polynomial whose sum and product of zeros are given. Okay, so let's do this. So you're given the sum of zeros, right, is minus 8 by 3. This is your first question. And you're also given the product of zeros. It is 4 by 3. Okay. So this is your sum and this is your product. Whenever you know the sum and product of zeros, you can write the quadratic you can find the quadratic polynomial using the formula x square minus sum of zeros into x plus product of the zeros. Okay, so just substitute x square minus sum is nothing but minus 8 by 3. Okay, so this is your sum and this is your product of the zeros. Plus the product of zeros is 4 by 3. Okay, if you take the LCM, 3 is the LCM, so you will have 3x square, minus into minus is plus 8, here you will have x here. Yeah, so the formula is x square minus sx plus p. So in place of s, I have substituted minus 8 by 3 into x plus 4 by 3. Okay, so you can take 3 as the LCM, so you have 3x square, minus into minus is plus 8x and then plus 4, right? So is equal to 0 because this is the polynomial. Okay, if you take 1 by 3 common out, or you can directly equate it to 0. So when you cross multiply, it's going to become 0. So the quadratic polynomial is 3x square plus 8x plus 4. This is the required quadratic polynomial. Okay. Now, this is the first thing. That is, using the sum and product of the zeros, you have to find the quadratic polynomial. So this is a quadratic polynomial of degree 2. Now, after that, you also have to find the zeros of these polynomials by factorization. So now, in order to find the zeros, you have to equate the polynomial to 0. So 3x square plus 8x plus 4 equal to 0. So what is the sum? The sum is your b, right? Sum and product. Okay, in order to do the factorization. So the sum is just b, that is plus 8. And what is the product? A into c. So 3 into 4, which is 12. So you have to find out two numbers whose product is 12 and sum is 8. So we can immediately think of 6 2s are 6 multiplied 6 times 2 is 12, 6 plus 2 is 8. So these are the factors. So for middle term, 8x will be written as 6x plus 2x plus 4 equal to 0. Take 3x common out. So you will have x plus 2. Again plus 2 common out, you will have x plus 2 equal to 0. So what are the factors between these two terms? What is common? X plus 2 is common. So you can take x plus 2 common, and what remains is 3x plus 2 equal to 0. So you have to equate each of these factors to 0 in order to find x. So x plus 2 equal to 0, or you have 3x plus 2 equal to 0. So x is equal to minus 2 is one of the 0 of the polynomial, and 3x equal to minus 2, x is equal to minus 2 by 3. Okay, therefore you can write the zeros are minus 2 comma minus 2 by 3. This is your final answer. Okay, so what have you done? Provided you are given the sum of the zeros and the product of the zeros, you will use this formula x square minus sx plus p. Substitute it, take the LCM, get the polynomial, and then equate it to 0 in order to find the zeros. Use middle term splitting. The sum is nothing but your b and product is nothing but A into C. 3 times 4, which is 12. And then find two numbers whose sum is 8 and say product is 12. Just substitute it in place of your middle term, factorize it, get the factors, equate them to 0 and find the value of x. So these are the zeros of the given quadratic polynomial. Let's move on to the second question. Okay, so this is your first question. Within, there's only one question and there are four questions within it, 4 subdivisions within it. So this is your 2.4 question number 1. Let's move on to question number 2. It is 21 by 8 is the sum and 5 by 16 is the product. Okay, so this is the sum of the zeros and this is the product of the zeros. So what is the formula that we learned? X square minus Sx plus P. Okay, so what is, just substitute x square minus, sum is nothing but 21 by 8 into x plus product of zeros is 5 by 16. So here the LCM is 16. So you'll have 16x square minus 8 multiplied by 2 is 16. So this multiplied by 2 multiplied to the numerator, that is 21. So it is 42x plus 5. Okay. So on the whole, this will be equal to 0. So this 16 will go off. Okay. So you'll have just 16x square, or even without equating it to 0, you can just take out this divided by 16, you can take it out common. So 1 by 16 you can take out common and the polynomial will be 16x square minus 42x plus 5. Okay, you can write that this is your required polynomial. Required quadratic polynomial. Right? Now, in order to find the 0, once you have found the polynomial, once you have written it, then you have to find the zeros. So to find the zeros, you have to equate the polynomial to 0. So let's equate 16x square minus 42x plus 5 equal to 0. So what is the sum and what is the product? Sum is nothing but minus 42. Okay, sum is always your B. Product is A into C. What is A into C? 16 multiplied by 5, which is 80. Okay, so here sum, you have to factorize 80. So the sum you can just take it as 40 and 2. Okay, in order for the sum to be minus 42, add 2 negative sign because the product is positive. So minus 40 minus 2 is minus 42. Minus 40 multiplied by minus 2, minus into minus is plus, 40 into 2 is 80. So you have got the factors for the middle term. Let's substitute 16x square minus 40x minus 2x plus 5 equal to 0. So take 8 common out, 8x common. So you'll have 2x minus 5, again minus 1 common, 2x minus 5 equal to 0. So what do you have? 2x minus 5 is the common factor. The other one is 8x minus 1 equal to 0. So either 2x minus 5 is equal to 0 or 8x minus 1 equal to 0. So here you have 8x equal to 1 and x is 1 by 8. 2x equal to 5 and x is nothing but 5 by 2. So therefore you can write finally the zeros are 5 by 2 and 1 by 8. These are your answers. Okay. Now let's move on to the third question. So this is your second question. The third question, third subdivision within your question number 1. So this particular question has four subdivisions under it, 4 questions under it. Okay, so this is just that it's just this one question which exists in exercise 2.4 and there are 4 different sub questions within it. Okay, so let's move on to question number 3. The question is minus 2 root 3 is the sum and product is minus 9. Okay, so let's do it. So this is your sum of the zeros and this is the product of the zeros. So what is the formula? X square minus Sx plus p. Okay, so this is the formula. Just substitute x square minus, sum is nothing but minus 2 root 3 multiplied by x plus of minus 9. So I'll just write minus 9. Okay, so you have x square minus into minus is plus 2 root 3 x minus 9. This is your required quadratic polynomial. Once you have got the required quadratic polynomial, you can find the zeros. So to find zeros, we have to equate the polynomial to 0. So x square plus 2 root 3x minus 9 equal to 0. What is the sum and what is the product? The sum is 2 root 3 and the product is minus 9. So you will have 3 root 3 and root 3. Okay. Because 3 3s are 9 and one of the 3 you can split it as root 3. So here if you put a negative sign to root 3, 3 root 3 minus root 3 is nothing but 2 root 3. And the product will be minus 9. So x square plus 3 root 3 x minus root 3 x minus 9 equal to 0. Take x common out. X plus 3 root 3 minus root 3 common out. X plus 3 root 3 equal to 0. So either x plus 3 root 3 you can take out common. What remains is just x minus root 3 equal to 0. So equate both the factors to 0. X plus 3 root 3 equal to 0, which means x is equal to minus 3 root 3. And x minus root 3 equal to 0, which means x is equal to root 3. So these are the zeros of the polynomial. Okay. I hope you are able to understand as we go along. Let's do the fourth question. And I think this is the last question of the exercise. Question number 4. Minus 3 by 2 root 5 is the sum and minus 1 by 2 is the product. So this is the sum of the zeros and this is the product of the zeros. Let's use the same method. X square minus Sx plus p is the formula. Let's substitute what is S. Minus 3 by 2 root 5 into x plus p. So plus into minus is minus 1 by 2. So what is the LCM? You can take 2 root 5 as the LCM. So 2 root 5 x square minus into minus is plus 3x minus you'll have a root 5. Okay. You can take 1 by 2 root 5 common out. What remains is 2 root 5 x square plus 3x minus root 5. So this is your required quadratic polynomial. Now to find zeros, we have to equate the polynomial to 0. So what is the polynomial? 2 root 5 x square plus 3x minus root 5 equal to 0. Get the sum and the product in order to do the factorization. Sum is 3 and product is minus 10. Right? So you can immediately think of 5 2s are 10. If you put a negative to the smaller number, you'll get the sum as positive. So you can split it now. 2 root 5 x square plus 5x minus 2x minus root 5 equal to 0. What can you take? You can take root 5x common out. So you'll have 2x plus root 5. Again minus 1 common out. 2x plus root 5. equal to 0. So 2x plus root 5 is common here. Root 5x minus 1 equal to 0. So you can either equate 2x plus root 5 equal to 0 or 2x equal to minus root 5 or x is equal to minus root 5 by 2 is one of the 0 and root 5x minus 1 equal to 0, which is root 5x is equal to 1 or x is equal to 1 by root 5. These two values are the zeros of the given polynomial. Okay, that's all. So here ends your exemplar exercise 2.4. I hope you understood. Please make sure you do all the exercise questions of both your NCERT and exemplar of each and every unit. I think that would give you a lot of practice in all the important concepts that you have in your chapter. So please do practice, and I hope you like this video. I hope it was useful. So that's all for today. Happy learning, happy weekend. Thank you.